Yo, yo, yo. What's up? What's up? Welcome back. Today we're working on my stream start screen. This is kind of what it looks like now. We're looking for like this kind of like old office vibe kind of setup where this will eventually get rendered onto the screen of the CRT, and we've been using this as an excuse to explore like 3D rendering as a whole. So we have like this scene set up. You can see we're like rotating the camera. We have shadows cast by a directional light source, as well as like diffuse lighting. And I think I'm kind of at like kind of towards the end of like things I would wanted to explore right now in this world. So I think that what we're gonna try to do today is just wrap up the rest of the stuff that needs to get done. So one is that we got shadows working yesterday, but not in with perspective enabled, which I would like to fix. So what we're seeing right now is like an orthographic render where as things get farther away, they don't actually get smaller like you would normally see in real life. And then I want to get this like text that's currently just like sitting on top of everything. I want it to be like on the CRT, and then I want to like port the CRT effects that we like made in Godot initially and run like a custom fragment shader on the screen here to like show this text. So a little bit of work to be done, but I'm pretty sure there's nothing that's like crazy hard to get done today. So I think that we're just going to try to move like kind of quick and maybe sacrifice some quality in some areas to get it done on stream, and then I'll loop back for a cleanup pass at the end off stream or something. All right, so the first thing to do here is start fixing our like perspective render. So just for like some context on the bug that we were seeing yesterday, if I go into main and I look at where we do our render, somewhere in here we say, hey, set perspective enable false, and I want to set that to true. And we can like take a look at what this looks like, and we can see that like the shadow that's being cast here, it looks like it's kind of like wiggling around on the table. But now you can see like the table's kind of getting bigger as it gets closer to the camera, but the shadow's not in the right spot. And it's like, why the hell is that happening? And so for background, for people who have not seen the other videos or whatever, what we're doing to render a shadow is we're essentially saying like, here is my scene. Here's my little CRT. And we have like a light coming in from like this way, essentially, right? And the light is like acting like the sun, in that it's not like a light bulb that's like radiating out light in different directions. The sun effectively acts like all light is coming from exactly the same direction. So what we do is we like put our camera like here where the light is, and we do like a perspectiveless render on the scene from this angle. And that gives us like a depth map. We can like then see what is the depth of each point in our image here. And what we do is like render that depth onto an image where you say like, you might have like brighter areas where there are, we see like maybe the monitor is like this and we're seeing it from the side, so it looks kind of like this. And then maybe like the desk is like a little bit brighter or darker because it's like, it's sitting on the desk and the desk is farther away or something, right? Like we're going to have like a basically darker for closer or farther, whatever. Then we render the scene again from like the perspective we actually care about, right? So we're like actually here rendering this way. And what we do is we like for each coordinate on like each corner of our object, we say, hey, where is this in this picture? So like, oh, this corner is like right here, and this corner is right here. And is my depth greater than or less than that, essentially? For each pixel, we say like, are we greater than or less than that? And then that's how we like generate our shadow. Because if our depth is like back here, we try to render back here and we say like, oh, we're deeper into the photo than we saw in this texture. So why is this warping? I was like doing some like debugging yesterday, and I think it's related to the fact that we had the same problem with the table as a whole. Like before, a couple streams ago, it was like clipping into itself, and it's like, why the fuck is that happening? And it turns out that if you draw like straight lines in like a perspective view, those correlate with like curved lines in this like warped world that we're working in after perspective is applied. And if you want to like interpolate between points, so we'll look at like a top-down view. Say my camera is looking at the table, like this is the table, and like this is my camera, right? So here he is from the top down. My camera's like got like looking at him like this. If I were to like work with the corners of this guy, which is like how you work with them initially, you only warp set each of these guys, and I were to like kind of warp them so that they are closer together towards the front of the camera and farther away towards the back. Let's see. Let's erase this. Actually, let's draw the table straight on so that's easier to think about. So we essentially warp the world so that these lines look straight. And then we draw the table like warped like we draw our perspective. So we say like, here is the front of the table, and the front of the table is going to look really big because we're close. And then we like make the table look like a quadrilateral like this. So we say like, oh, the back's farther away, even though in reality these are like the same distance apart. As we start like walking down this line, essentially like the curve of what that line should look like is like no longer straight. And it turns out that this line needs to be, for if we were to like linearly interpolate pixel by pixel on our camera, it turns out that we need to map this to like 1 over the distance essentially, because that's related to our perspective here. Now, where this gets interesting is when we're rendering from the light source over here, right? We have like the sun over here, and he's casting light this way. All of a sudden, we don't have this like same concept where we can say, we can't like just say, oh, when we like look at this position, we can't interpolate that in this perspective, because in this perspective, this is like some combination of X, Y, and Z, this like weird off-axis thing. And so I think what we have to do is I think we have to like take our position from the perspective of our camera, undo all of the perspective stuff, then look up the position in like the light source depth map. And we can kind of prove that that's the problem to some extent by trying to reduce the interpolation problem, right? So our table, he's made up of 2 triangles essentially, like one triangle here and one triangle here. And if the problem is like related to interpolation and warping and perspective, if we just like split this up into a ton of smaller triangles, then we should see the shadows get a lot better. And so we can like open up Blender and we can import our table object. Import obj, I think is what we're exporting as. So we can go into our stream start screen and look at the table. Right, so if we look at this guy, he's got essentially 2 big triangles, and we can just select everything, or maybe like just we'll just look at these 2 faces, and we'll just say there's like a subdivide button somewhere here, and we'll just hit this a few times. Essentially make it so that now our interpolating between these corners is going to have like a lot less error, theoretically. And so we'll just like re-export this over top of the one that we just had, which is somewhere. Stream start screen. And we want to triangulate the mesh before we export it. And we don't care about materials, so don't fucking export those. Cool. And now if we rerun this same scene, I think we should see something that looks like pretty sane. Right, like that looks a lot better. Like a lot better. Like the shadow is essentially mapping to the table correctly. So I think what we want to do is we actually want to undo that change. And we can just essentially reverse everything we do to do perspective on our guy. So we'll like apply perspective. And then in our fragment shader, when we're iterating pixel by pixel instead of vertex by vertex, we can just undo that mapping and map back to the white space. So let's undo this table thing. I think it's like this. Yeah, okay. And we can go into our 3D fragment shader. Can I get some like syntax highlighting here? TS install GLSL. Will that do it? Hey, that's kind of cool. Yeah, that looks a lot nicer. Nice, 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 nice. Okay, so what we can essentially do is we can go into our vertex shader, and we see that there's like all this stuff that we do when perspective is enabled. We do this, and then we do this, and we can just undo that all before applying our light transform. So let's just see what that looks like. So I guess we have to walk like front backwards to forward. So we'll say, I guess first we actually have to provide the vertex or the fragment shader with the position. So we'll say out vec for position, and here we'll just give him the same position that we're already exporting as our output here. And the reason to do this is so that we can like access this interpolated, but exactly as we expected. So we can say here, hey, I want an input. That's our position. And then we just basically say everything that we did up to this point, we just like undo it. So we say world position, I guess we'll call it, is equal to the input position, which is in perspective modified camera space. And I guess maybe calling him world pause isn't what we want. We're eventually trying to get to light position. And so we'll just undo everything. So we'll say light pause.x times equals aspect. So which means that we need the access to the aspect ratio in here. Then since we're in this variant, we are going to undo all of these things. So a times equals -1, you just apply that again, and that should be the same. So light pause z times equals -1. Let's actually change the direction of these now so we don't forget. And I'm pretty sure that this like 1 over z over 10, I'm pretty sure that ends up being the same thing. We have like y equals 1 over x over 10, which is the same as putting these in brackets and multiplying by 10. So then you have x. If we're trying to get x back from this after doing this, we would just swap all of the arguments. We say like x times 10 is equal to 1 over y, and then we divide by 10 to get this to in the same spot, and we're back in the same spot. So I think that we can just apply the same mapping again. So we say light pause z is equal to light pause z blah blah blah, and then here we scaled our xy positions by z, so we'd say light pause xy is multiply equal to undo the divide. Then we just have to get back to world space. So we apply this like view matrix to get us from the world into camera space, and so we can just do the inverse of what we did there. So we have to get our view matrix here, which means that here we can just say light pause is equal to view times light pause, because we usually use the inverse. And then from here, we should just be able to apply the light transform. Light transform. And then from here, I think that we should be in light space, which means that we don't need to do all this light space stuff over here. Bang, bang, boom. I think. We'll see, we'll see, we'll see, we'll see, we'll see. And I guess we also have to only do this if perspective mode is enabled. So we'll pull in that uniform as well. So we say if enable perspective, we do this. Right? Yeah, that seems reasonable. Otherwise, we do this, where we invert this divide by 10. And then I guess we also have to redo this z divide by 10, I guess. Because we did that when we rendered the light. So we say light pause dot z divide equals 10. Is that it? Oh, and we have to reapply the aspect ratio. And I think that's it. What a pain, but it is what it is. Okay. So I think if we run this now, we should just see the same... Oops. Some crashes, nice. Okay, so we were using this thing new light pause before, so we'll just delete those because I think that was like garbage code that we didn't need. Outvert undeclared. Oh, so here this is supposed to be light pause, and it's supposed to be light pause. Light transform undeclared. Because we need to, again, pull in that uniform so that it's accessible from our fragment shader. Okay, so there, it looks like, I think that's right. So our table object is still the low poly one, I think. File, we'll just delete this, and we'll double check that if we import our low poly table, yeah, we do see the triangles, yeah. Okay, so that's pretty straightforward. It took a while for me to figure this out yesterday, that this is the problem. But yeah, looking pretty good. I would probably argue that doing it this way is now starting to get a little crazy, right? Like, applying perspective manually like this and then unapplying it here kind of sucks. And so usually people apply perspective with like these like perspective matrices. And that's starting to make more sense now, right? Because then we can, instead of like manually step-by-step undoing the math that we did here, we could have like a combined view perspective matrix, and we could just invert that and do like one matrix transformation to go from like view space to light space. Where like this way there's like a lot more math involved. So I'll probably adjust to do that, but that'll probably be like another like off-screen fix thing because just want to keep moving. Let's keep it moving. Easy fix, easy fix. Yeah. So I think that kind of like calls the Shadow Saga somewhat done. I probably want the shadow to be a little less aggressive, right? It looks like pretty dark, and I probably want it to be like a little smaller too. So I think I'm just gonna like tweak a couple values in here. So here we have like ambient lighting essentially done by we apply our light in this stuff, and then we just say like, hey, but also like if it's too fucking dark, just like pretend it's not dark at all. Like, so we can just say like, we'll apply ambient lighting by essentially setting a minimum value for the light. Okay. I guess actually we should set a minimum value for, we might have to be a little careful with like the light color as well here. Yeah, let's see. Also, I'm timesing by the maximum of something times color times lit mul. But what if my color is a vector? That seems reasonable. Let's just set a color in here and see, like, double check that it looks okay. So let's just set this to blue or something and see if our scene looks blue as fuck. Yeah, okay, sure. That seems reasonable. Our shadows are not looking quite right here anymore. So I think that I have to be careful with my ambient lighting thing here. Yeah, I do have to be careful with that. So I guess the ambient lighting should be like float ambient is going to be like 0.2 times the light color, I guess. Which will make this a 3-element vector for RGB. This dot product is a scalar that is like how bright should I be from angle. The lit multiplier is just a float, okay? So we can say probably that we have like brightness is this. We'll call this like diffuse brightness is this guy. And maybe then we do like diffuse plus ambient. Does that make more sense? So here we'll do diffuse plus ambient. And this should be vec3 1.0. Let's see if that looks reasonable. He doesn't like that. Okay, so this is color XYZ is equal to... Both of these have to be multiplied by the color. Like this, I guess? Yeah, that seems reasonable. Still doesn't like that. Because I'm doing a minimum of float and vec3, because these should be vec3s. Am I high? Okay. Something there still doesn't look right. That doesn't look like blue enough. Is diffuse doing the right thing there? Diffuse is not multiplied by the light color here. Oops. Okay, so that's blue. And let's look at the ambient light. Also blue. Okay, and then if we do diffuse plus ambient, that looks... I think that looks pretty reasonable. That seems about like what I thought it should look like. Cool. Okay, so I didn't actually want a blue light. I was just using that for testing. So where do I set the light color in here? Here. So what do I actually want? I want like some like depressing fucking yellow. Right, so something that's like kind of on the verge of being white, but is just like depressing instead. So this looks probably like what I'm looking for. So this is like 200 or 255, and this is like half. Okay, so this is like blue is like 0.5. So this would, what's 255 over 2? 128. And then let's say green is 3/4. So yeah, we'll just call both those 3/4. Fuck it. And we'll see. A little too yellow. Also, what's going on with our shadow map on the back there? This is looking kind of odd, eh? So let's see if that's coming from diffuse or ambient. Looks like it's coming from our diffuse, which makes sense. Yeah, because our ambient light looks like totally reasonable there. And so when I add them together, is it like why is it like totally black back there? Probably because our diffuse has to be capped out at 0. It's probably going under 0 and we add back in the ambient. It's not adding from 0, but adding from like some negative number. So we should just like max this with 0. And probably that fixes it, would be my guess. Yeah, that looks a lot better. That looks a lot better. All right. Light position, I'm not really quite happy with. So let's just kind of put him like kind of up higher, I guess. So his X, I guess I want his like X and Z movement to be like reduced in comparison to Y. So we'll just like set these to 0.5 and see what that looks like. Yeah, I like that a lot better. I do like that better. Maybe a little more. Maybe like a little more on like X. Weird. I thought that would be less on Z. I want it to be like more to the left. Oh, my X and Z axes are just backwards in my head. I see. So I want like low X, high Z. Yeah, there we go. That looks pretty good. Okay, let's stick the camera. Kind of, instead of doing this like rotating thing, let's kind of position the camera so that we can see the screen in like reasonably high detail. So somewhere we set the camera transform. here, we look at this guy. And so, wait, is that where I do it? I've got some like, here, I was doing some cleanup, it didn't quite finish. So this would be view matrix. There we go. And we set the view matrix here, and here we can just, we'll do a look at, and we want to look at like approximately the center of the screen. So we can probably assume that the screen is close to 0, 0, 0. It's probably a little bit out on X or Z. And now we just need to set like a position of our camera. So we're going to be out a little bit in X, and out a little bit in Z, but not by like a ton. So let's like try like 0.5, 0.5 fixed. And I want to go much lower than that. Much, much, much lower. So let's try like a 0.3. That's looking like pretty decent. I probably want to get closer to the thing as a whole. Too close. That's fucking something up. So we'll increase these a little bit. So I don't know what we've done here, but we're just like somehow like inside something that we shouldn't be. Yeah, so maybe we can't get too close yet, which is a little unfortunate. That's okay. And then I actually... Shit. I did want to be, like, lower down than this. Right? So maybe, like, I do have to come out a little bit on X and Z temporarily. Oopsies. Yeah, I wonder what's going on here. Something here is just like, that's totally fucked. Is that related to perspective? I'm curious now. Interesting. Interesting. So, it looks like when I get too close, it looks like both the shadow and the fucking... The shadow and rendering gets, like, kind of fucked up. Probably something's going, like, inside the camera. Hello, what's up? What's up? Yeah, it's odd. That's odd. Okay. Well, for now, we'll... I guess we kind of have to fix that, huh? Because if I want to, like, see the text on the screen, that's going to be kind of rough. I did want to be looking from... Oopsies, I don't want to change the light position. I want to change my eyeball position, which is not the light direction, but the view matrix. So let's try looking from the left, because I wanted to look from the left anyways. Oops. One of these has to be positive. Not that one. Yeah, I don't know why the shadows look so fucked up. Can we go back to being, like, a little higher up? Yeah, what happened here? Oh, because maybe we're unconditionally applying perspective. Hold on, let's set perspective back on. Perspective. True. It could be that the fixes we made... No, something there is just, like, totally fucked. Interesting. What did we do? What did we do? Let's go back to no perspective. Okay. And go back to our 3D fragment shader. And can we, like, git status, git add -u, git commit -m, smiley face, just so that we have, like, something to loop back on. And I want to go back to our old shaders and see if they still look like shit. We must have made a mistake somewhere in there. Because if I go back, that looks a lot more reasonable. Okay. So we just have to go look a little bit more closely. Oops. So let's go back to where we were a few seconds ago. Git restore staged. Okay. Okay. And we're going to look at 3D vertex and 3D fragment. And we're going to double check that we didn't do something fucking stupid here. Smoney Monkey, thanks for the sub. Appreciate it. Okay. So we just got to walk this line by line and make sure that we're doing everything backwards in the right order. So aspect should be applied whether or not we're in perspective. So that's already one mistake fixed. Light pause z times equals -1. Light pause z equals 1 over this. So we already did the math there, and then a times equals, and then in this side it's times equals. We know that after we applied the light, we were always in this case. So I think that probably that was just like a orthographic bug there, and that looks okay. And then if we go back to perspective, does it also look okay? True. Yeah, okay. That looks better. So there was just like a slight bug in our shadow mapping there. And I'd be curious to see if we get a little closer again, if we're still fucked up. So let's just get right up in there. And that is clearly still fucking busted. So it could be that this is why I don't have like a near clip plane on. So it could be that like when we get like really, really close to stuff, it just gets like wonky. So that's okay. For now, we can do this. It would be nice to get a little bit closer. So can we like kind of like test our luck and just try to get like as close as we can without it being like stupid? Okay, that's looking good. We can get a little closer on Y as well. Okay, and then if we get maybe a little bit farther out on Z, so that we're looking kind of more straight on. No, I want to get a little farther on X. I want to like see like more of the screen itself. Okay, that's like good enough for now. Maybe even less on Z. Hey, perspective shadows look better. What ended up being the issue? Yeah, it was like the same thing as our Z. Our like the table used to like clip into itself, and it's like the same problem where interpolating two vertices in like world space in the fragment shader doesn't work after perspective has been applied. So you have to like kind of like warp your coordinate system so that linear interpolation in screen space works correctly. And so what we did was we just ended up inverting like our vertex position in the fragment shader and then applying the light transform from the fragment shader instead of the vertex shader, if that makes sense. Okay. Yeah, that's not too bad. I think that's enough that we'll be able to see if we are doing this right. I'll have to like look into the perspective. Well, I'll make a note to come back and look at why I can't get too close to the objects. But I'm almost certain that it has something to do with like a near clip plane that's not implemented. Okay, so we spent some time kind of doing, I guess, this. I don't really know. We'll call this like tweak camera position and lighting, etc. And let's start trying to get like this text right on the CRT. Obviously, we'll have to get closer to make it readable, or scale up the CRT. Yeah, let's just try that. Let's try taking the monitor and the screen and just making them bigger. Scale, so we can just say like 2.0, 2.0, 2.0 for now. And if that gets big enough, okay. We also, okay, maybe 2's a little big. And we'll also have to do some vertical movement, I guess, of the table to offset it. Or of these guys. So we'll say, what? After we scale them, we move them up by some amount of Y, I guess. Like this. And I guess we should say let monitor transform is equal to this guy. And then we can apply the monitor transform to both these. Monitor transform. I guess we could also do this in Blender, where it's like easier to move things around with our hands, but fuck it, you know? Mismatched delimiter, because I didn't put a bracket here. Too high. A little better. We need to go a little bit lower. Not that it matters, but... Okay. One more last tweak. I just want to get the camera a little bit lower down. So that it's kind of like more head on. Maybe we look at 0.08 and go even a little higher up. Fuck it. Well, that works for me for now. Good enough for now. Okay, so now what I wanted to do is I wanted to start putting that text on the CRT itself. So we'll say that we're starting that at 3620. So the first thing to do is in our render loop, we do this like light render, then we render our like 3D scene, which should probably be split out into its own function, but it's not right now. And then we render like this stuff on the screen directly. And we can just kind of like split out a similar thing where we say render light depth. We can say render text to texture. And we'll do the same thing where we set up this like frame buffer that we're going to render to. We clear the color buffer and the depth buffer on this guy. And we don't do like a mesh render. We do all of this stuff that we are currently doing for text rendering. Right? All of this. Boom. And then we should be able to just slap that on as the texture of the monitors of the screen. I think. We'll see. We'll see. So here we render the light depth. Here we say let screen text is equal to self.render text to texture with now. And here we should be able to say before we render the objects, we can say that the screen texture is equal to the thing we just rendered. And then we have to delete that after. So let's see. Look at that! Wow! I love it when stuff works. That's pretty cool. That's pretty cool. So it's Y and X are flipped. But that's looking, we're starting to look pretty close. Are you using a bitmap font? So we are rendering using FreeType2 to get us a signed distance field. And then we use that signed distance field to like apply some blending on the font and stuff. That's pretty sick. Okay. So now when we put him on the screen, we're actually probably going to want to do some like custom fragment shader stuff, right? Because like this looks like ass. And so we could either do that from within the screen texture, or we could do it. So we could do it when we create the texture that we're putting on the screen, or we could do it when we're rendering the stuff that we see in the cursor. And I guess it's less code juggling right now to do it when we render the text. Because right now we don't have any way to apply custom shaders to our objects. And if I were to be doing like something that I wanted to work on for longer, I would say it makes sense to be able to attach custom fragment shaders to individual components. But we're not doing that. So we can just, when we use our glyph renderer, where when we render this texture, we can just apply a second fragment shader to it after to like adjust it to our whims. Which seems reasonable to me. Which seems reasonable. Can get a pretty easy visual eye win by pumping up the shadow map resolution. Yeah, you're right. I was kind of hoping that 1024 by 1024 was big enough, but let's throw a little 2048 by 2048 in there and see if it looks better. It's still quite jagged. So it could actually be like a interpolation thing. Oh, no. Could also limit the view of the light. Yeah, that makes sense. Yeah, I can see why that's happening, but we can probably leave this for now. I'm okay with that. Let's think. We could also argue that like shadows maybe shouldn't be applied to the screen. You could argue that because the screen is like emitting its own light. I'm just trying to think of what I want to do. You know what? Fuck it. Let's apply extra effects to the screen itself. Let's just get that going. So I guess what we want to do is, do we just want to use our mesh renderer here? What's the easiest way for us to inject like a custom fragment shader? Because like almost everything that we're doing is going to be very much the same, right? We still have all of these like camera transforms, we have perspective, we have blah blah blah. But like what we might want to have like some like custom extra behavior. Thinking. I'm flipping back and forth. Flip-flopping. Okay, I'm going to just adjust the texture for now because that's easier. So we'll make a new renderer that basically takes in a texture, renders it directly, and applies a custom fragment shader on top. And that like allows us to do essentially post-processing effects in 2D, which is essentially what we want here, probably. Okay, so something in here, probably the cursor renderer is like the closest thing to that. He uses color vertex and color fragment. So what does color vertex do? He takes in a 2D vertex and an aspect ratio and renders it. Cool. You could have a texture that masks the screen, then in the fragment shader, handle it there. It may be simpler than multiple fragment shaders. Oh yeah, that's true. Could do that. I'll think about it. I think for now I'm just gonna start with something, and then we can iterate from there. So I'm gonna start with just modifying the texture before I write it. Okay. So this seems reasonable, except we also need UVs, so sounds good, gotta run, good luck. See you later. I guess, like, we could try to reuse one of our vertex shaders. In fact, this one that's 2D, that takes in a vertex and a texture coordinate, and forwards the texture coordinate. This is like almost exactly what we want. So we can probably reuse that. And then we'll just make a new fragment shader for the screen itself. Okay, that seems reasonable. And so let's go into our, we can make a source. We'll call this like monitor post-process. Monitor texture post-process. Screen texture post-process. Yeah, that looks like right. Screen text post-process. And he's going to be very similar to our cursor renderer, so I'm just going to like copy paste this whole thing. And we will adjust as we need to. So we decided just now that he's going to use this thing that we have called vertex.glosal, who I assume is used by someone. Vertex.glsl is used by our glyph renderer, which means that our glyph renderer has this generate square buffer, function, which we're probably going to want to copy paste. Cool, cool, cool. Okay, so that will create a square in the format that this shader expects. Yep, seems reasonable. Which will also require this function to be copy pasted. And, you know, in reality, we should put some like fix me copy paste frowny face, because they don't just happen to be the same. They are using the exact same vertex shader, which has the exact same inputs. So we should deduplicate that, right? But for now, just to get myself moving, I'm not going to do that. This is no longer a cursor renderer. This is a screen text post processor. I don't know. We'll call it that for now. He has a program associated with him, the shaders that he's going to run on the GPU. He has a buffer associated with him so that he can draw a square. That makes sense. And he has a reference to OpenGL and an aspect ratio. All of those are still important here. So we will leave them. We will leave them. Screen text post processor. We need to include this from main, so we say mod screen text post process. And this guy has shader input as well, so we have to copy paste that as well. And eventually I will deduplicate, I promise. I promise, I promise, I promise. But maybe not right this second. So this shader input is this like repr packed thing. Cool. Cool, cool, cool. And okay, so we can kind of just walk through this and see what he does. So he creates a vertex array and he binds it. He generates a square buffer. Great, binds that. Stride is wrong here. Stride is going to be more like what we see here. In fact, all of this stuff is more correct from the glyph renderer, not the one we copied from before. We have shader input offset is a macro here, gross. Just lots of fix me copy pasta. But we just want to get into a reasonable spot. All of that otherwise seems okay. And here now we just return our thing. So oops, and we also have to get the aspect ratio location. Okay, cool. Screen text post processor. Okay, so our render inputs are going to have the texture as one of the many things that we get as an input. Native texture. And we don't have like a width and height that we're trying to render. We're just trying to render that texture as the full size of the screen. And so we don't actually have to update our vertices at all. But we do have to update the aspect ratio. And we do have to bind the texture. So GL uniform 1 F32. Nope, it's GL activate texture. And we say glow texture 0 something. And then we bind it. We bind the texture as something. I've done this before, so we can just look at where we did this. Bind texture. Bind glow texture 2D. Yeah. Texture 2D. Okay. Okay. Try wrapping in some. Then we draw our quad as a triangle strip. And when we drop this guy, we clean him up. All right. All that seems reasonable. Now, which fragment shader are we using here? Color fragment. So we'll make a new fragment shader. Screen fragment.glsl. And we'll start by just copy pasting this guy. And, oopsies, we've named him the wrong thing, so we're going to go in and quickly fix that. GLSL. Nice. And we open screen fragment GLSL instead. Okay, nice. And for now, let's just set the whole screen to be black. Just to prove to ourselves that everything else is hooked up correctly. So we will go into main, and we will add, as one of our many things that we do, is we create a screen text post processor, which is a screen text post processor. Nice. Okay. Then when we start ourselves up, we're just going to make one of those guys. So we'll just kind of screen text post processor is screen text post processor new. Right? And he can fail with create screen text post processor. Sure. Which means that we need that error to exist. Yo. And where are my errors defined? Over here. So here we say failed to create screen text post processor. Was it OR or ER? Fuck. Screen text post processor. I think it's O. I think I said it. I don't even really care if it's right or wrong. I just want to know which one I used. It looks like that's not the one I used. Create screen text post processor, and I didn't say renderer. I'm so close. I guess we'll copy paste, and any typos that I made will just stay typoed, but be consistent. Okay. Now we can upload this guy here, or not upload, like make him one of our guys. Great. But the names don't match because here I used an E, not an O. Cool. Cool. So now when I render, all of this to say that I should be able to say, I render the text to texture. And now I can just run self screen text post processor render with the texture. And the aspect. And if we did everything right, we should see a black screen. Boom. That's sick. Love it when things just work. Let's try making it a not black screen. So we'll look at the screen fragment shader and we'll try making it white just to make sure that, like, we are applying this the way that we want. Now we see nothing. So clearly we fucked up. We fucked up somewhere. We just got lucky that the black was what we wanted. And it's because we're not actually using the fragment shader we want. Screen fragment. Now do we see white? Now we see it crashing. Perfect. Perfect. And it's because we need vec for out, vec for out color, and not the input uniform. Black. Not good. Not good at all. Okay. So we need to think about what we've done wrong. So we will double check, first of all, that if we don't try to do anything to this guy, if we don't try to use this guy, our texture does have the text that we rendered to it still. Okay, so we do have like some confidence that by running this shader at all, we are destroying our texture. Right? So that's a good sign. It could be that we're trying to overwrite a texture that we're rendering to. We're trying to like both read and write from it, and it might not like that. So we could try making a new texture to render to and returning that. So we could say let text2 is create a texture with default parameters, and we render to text2. Oops, we do not render to text2. We bind text2 as what we're rendering to. So actually we want to do something similar here where we create a frame buffer. Oh, interesting. It's shocking that this was actually working at all, because we were rendering the text to a depth texture, which is just not what we're trying to do at all in this scenario. So that would probably explain why it's bugging the fuck out. Okay, so let's fix that. Let's fix that. So what we should be doing is, instead of doing a depth texture render, we should do a setup color texture render, which is very similar. And we'll say, fix me copy pasta with depth texture. And let's see what's in here. So he creates a texture and he binds them with depth component. Nope, RGB. And other than that, he creates a frame buffer, binds the frame buffer, sets the frame buffer as a depth attachment. Nope, color attachment 0. Oopsies, I didn't mean to quit there. GL, what was it? Oh, I'm in the wrong folder. GL util. Where was I? So color attachment 0, bind the texture. Our buffers are now color attachment 0. And we set those as our draw buffers. Check the frame buffer status. Crash if it's not good, and return the texture and the frame buffer. Sick. So here now, instead of doing setup depth texture render, we should do GL util setup color texture render. Bing, bang, boom. Let's not do our post-processing, because we just want to see if we still see the text on the screen at all, which we do. Nice. Cool. So now if we do our post-processing and we set the screen to be white, it's white, because we are now rendering through the color texture like we meant to, instead of the depth one. And if we go to the screen, what do we call our thing? Screen text post-process. Let's just, it's the, screen fragment shader. Let's set this to black. We set to black. We're still good. Nice. Okay. So we have a shader that's running on this guy, which is pretty sick. And now what we need to do is we want to sample the original texture and apply some transformation to it. So we can say uniform sampler 2D in text, which is at this point the same as our output texture, which is going to be kind of fucking weird. And let's now, instead of doing this, let's sample. We'll sample it. So say vec for sampled is equal to texture in text at our UV coordinates, which means that our vertex shader, he is outputting a position, and that position is in UV space, I hope. Yep, is in text in UV space. So we can say in vec to UV, and we just use that to sample our texture, and we just write the sample thing back. And if we are doing this right, instead of seeing black, we should see just the original texture again. And it's not doing jack shit, so we're clearly doing something fucking wrong. Clearly. But we're not crashing, so that's a good sign. Let's just double check. If we sample it and add 100, we get a white screen, so that's a good sign, right? That means that like our fragment shader is still making it to the end. And so we could argue that maybe rendering this to the texture that we're reading from is no good. So we could do this again, where we say, hey, please bind a new frame buffer with a new texture. Yeah, and we'll return the new texture, text2. Okay. And here we're rendering with the original texture. Everything else seems to be making sense. And then we delete the frame buffer and the original texture. Okay. So what happens if we do that? Still nothing. Still nothing. So let's look again. So it's possible that our UV coordinates are not being mapped correctly. So let's get our vertex shader. And it's also possible that we have not bound our input texture correctly. So we can look at that. So we'll start with the vertex shader here. It's simple. He takes the texture coordinate input, he sets it to the vertex position, and in our other guy, our like Rust side of things, which is called screen text post-process, we do have our texture coordinates as 0, 0, 0, 1, 1, 0, 1, 0, 1, 1. So these should be right. And we could also check our UV coordinates by, instead of sampling the texture, we could just set our color to be vec2 or vec4 UV1, 1. Maybe 0. So we want blue, no blue. We want to see our UV coordinates, and we want to see them with an alpha of 1. Okay, so that's interesting. It's just totally fucked, right? Which is interesting. Very interesting. Interesting. So what would cause that? What would cause that? Let's look at our binding of our texture coordinates. So we say they're floats. We say that they're at the texture coordinate offset. We say that it's position 1 with 2 things, non-normalized. Interesting. So I'm trying to think about like how to debug this. So let's just double check. So if we set it to white, oopsies, what am I doing? Screen fragment. We just say this is just vec4 1.0. That applies cleanly. So it's more that like our UV coordinates are just like fucked. Can I do UVX? Let's just only try to see red. And there is like some sort of red moving over there, but not like that cleanly. And if we do Y, the Y and the X are actually like lined up with each other. So it really just does seem like our UV coordinates are just not getting propagated correctly. Maybe we have to match the names. That's possible. So here we call it vert. So if we call it vert here. Aha! Okay. So it looks like the GLSL bindings between the vertex and fragment shaders are more intelligent than I thought. I thought it was just going to be like I put output a thing, I input a thing, but it actually, you have to match the names, which is interesting. I didn't know that. Okay, so let's go back to looking at like the sample thing, and we don't have to wrap this in vec4 anymore. We can just look at our sample thing and say don't change jack shit. And we do see something that like resembles what we were trying to render, but why is it fucking changed size, man? You know? Like, hello, why you should be exactly the same. And so, why would that be? Why would that be, right? If we return the original texture, he's small, reasonable, and we return the new texture, and it's like, big boy time. So let's think about that. I have a texture, I've bound it, I'm sampling it. And I'm sampling it from 0 to 1. That's very odd. I don't really understand. My texture coordinates come in, and let's double check that the texture coordinates are sane. So we can say vec3 UV or vert X, vert Y 0, 1.0, right? We'll see the x position in red, y position in green, nothing blue, and then we'll have alpha. Doesn't fucking like that because this is supposed to be vec 4. That makes sense. And it almost looks like my texture coordinates are like too big compared to what we were seeing. So let's go back and look at our setup here. And are we just like fucking up our texture coordinates here? We have 0 and 1. Okay. I'm thinking. We're thinking. It's like somehow bound in correctly. Like if we were to, instead of mapping the UV coordinates here, if we just said that we were using invert 2.0 minus 1.0, can I just use that as well for here? Can I just use vert is equal to v just temporarily, just to see? Like that's more what, is that more what I expect? No, that's negative 1 and 1. It's almost like I can just use invert xy. And is that the same as using our texture chord? I almost need like a reference. Oops. Oopsies. I think that's like more red than if I use texture chord. Oh, hold on. Generate. What am I looking for? I'm looking for the screen texture post-processor. So the box he's creating is negative 1 to 1, but we're adjusting our vertex coordinates in here, which is just fucking wrong. So, this should be 0. Like this. Yeah. That makes more sense. There we go. Let's try running that again. It looks fucked. Hold on. 0, 0, 0, 1. 1, 0, 0, 0, 1, 1. Okay, there we go. I think that's better. That makes more sense to me. So now if I use the texture chord to sample, hopefully we don't just like get 2 times as big now. I can't actually tell if that's right or not. That seems reasonable to me. That does seem reasonable. Okay. So now what do we want to do to this guy? Well, we want to swap his y and x positions. So can we, I wonder if you could do like dot yx there. Close. I can't tell if he's backwards in both y and x. I think he is. So we can do maybe a negative vert yx. Nope. He's only negative y. So we'll say vec4 or vec2 adjusted chord is equal to vert dot yx and vert dot y, or adjusted chord dot y times equals negative 1. We can use adjusted chord here. Boom. Then we want to like maybe multiply our thing by 2 so that it like gets like more in the center of the screen. Nice. But we also want to clamp that to the range 0 to 1 so that we don't wrap. So I guess if adjusted chord.x greater than 1.0, or adjusted chord.y is greater than 1.0, or adjusted chord.x is less than 0, or adjusted chord.y is less than 0. Discard, right? We don't want to wrap. We just want to, like, get the fuck out. That's not good. X greater than 1, Y greater than 1, X less than 0, Y less than 0. Oh, because we flipped it. Fuck. This would be 1.0 minus adjusted chord.y, so that we stay in the range 0 to 1. We are close, except we are now, for some reason, off screen. Am I using the right fucking things here? We have an input vertex, we're flipping as y and x, inverting as y. So if I do nothing here, we should see the full screen. Yep, okay. We invert y, we should still see the full screen covered. That's weird. That's super weird. What the fuck? How come when I flip him by, when I do 1 minus, I would expect to see almost the exact same thing? My coordinate range is not what I expect. Let's just outcolor vec for adjusted chord xy 0, 1. I just want to see it. I want to see it with my eyeballs. It's like mostly red, which is not what I expect at all. Oh, because this is a times equals. I'm a fucking idiot. There we go. That's what I expect to see. That is what I expect. Okay. Then we go back to showing the sample thing. And that looks a lot nicer. How'd I get that CRT? I modeled it in Blender. It's actually a pretty easy model, actually. If you just look at it, it's like, you know, pretty straightforward. Not a lot going on here. Just like a few vertices. There's, if you go to my YouTube channel, the playlist for creating a stream intro screen, I'm pretty sure I model it in one of the videos in there. So you'll be able to find it if you want to go back and look. And YouTube is linked in the Twitch description if you can't find it. Okay. So let's make everything smaller by multiplying our UV coordinates. Okay, so everything's smaller, and then we need to kind of offset it. So how do we do that? We offset it by adding 0.25 or something. That seems right. Subtracting 0.25? Why? Am I high? I would have thought that that would have put us... I don't know why it's like so... kind of like offset. I guess because we've been like, do we have like aspect ratio adjustment going on? No. I would think that this is in the range 0 to 1. Now it's in the range 0 to 2. Oh, I see. So I need to minus equal 0.5, not 0.25 to get us like a quarter in. Okay, that's looking pretty decent, right? That's like kind of like about the right size. And now what we can do is we can, instead of discarding here, we probably just want our out color to be black. So vec for 0.0, 0.0, 0.0, 1.0. And then we return early, I guess. I don't know if you're allowed to do early returns in GLSL, but we'll see. Otherwise, we get that. And it's kind of odd also that it's... I'm surprised that like parts of the screen look like really black, you know? But I guess that's because they're out of the range. I see. So we have gray on the back for the most of the thing and black otherwise. So we actually probably want to adjust our I see. So what's happening here is we have like a clear color of gray, and we rendered to a texture that we're now kind of warping. And so anywhere that like wasn't that color before needs to be set to that color. And in reality, we shouldn't be clearing with gray on this texture at all. So let's go over here and let's just say that our clear color will be black for now. Clear color. So we'll just set it to black. Everything is black when we clear. Let's just see what that looks like now. Okay. That's now we have like this like thing that's like consistent. Our background for the whole world is wrong, but like fuck it, who cares, right? We'll deal with that later. And now when we sample the texture, now we can start doing our like post-processing effects. So we actually made some of these in Godot already when we did this before. When we did like a kind of like quick setup to see if we like liked the look of this at all, which means that we should be able to just yoink our shader code that we did over here, and it should be like pretty damn close to what we want. Where do shaders live in Godot? Am I high? Do I have, is it like hidden somewhere? Did we not save it? I would be upset if we didn't save it. Nix shell p Godot. Let's see if we can find it in here. Maybe I need to write Godot 4. What is happening? Undefined variable Godot 4. Godot has been renamed to Godot 3 to distinguish from version 4. So Godot underscore 4 maybe, was it? God damn. There we go. Godot project.godot. Can we find our shader code in here? Or did we lose it? Did we lose it? We had it like somewhere in like our screen, I guess. We would have had a shader associated with him. No, not a shadow mesh. Surface, material, texture. I swear that we wrote a shader here. Did we just lose it? That sucks. All right, like if I hit play here. Very cool. He just crashes. Love that. Maybe this is supposed to be a Godot 3 project. Oh. Where am I? I'm in this. I guess I just didn't make a Git project for this before, which kind of sucks. Let's try Godot 3 and see if it runs. And if we didn't save this our shaders before, then we'll just have to live with the consequences and rewrite them, because it was pretty straightforward what we did. It's just annoying if it's not right. Why does it think that I have like path planner? Like, what does it think I'm doing here? I don't know. Weird. Yeah, okay. It's fucked. It's over. Okay, we'll just write it from scratch. It sucks that I could have sworn that we did this already. I like remember very specifically doing this. But yeah, it's not jumping out at me anywhere. Unless we called it like something test. Nah. Must just be gone. Must be gone. Oh wait, no. Wait, here we go. One of these must be it. Nah. Okay, we're calling it. We're calling it. We'll just write it again. That's okay. Not the end of the world. Not the end of the world. Okay, so we'll go into our fragment shader. We're probably in the wrong window. We probably want it to be in this one. Nice. And in our fragment shader, we can just start doing what we did before. Like with the output color, our sampling should only, like if we want it to look green, we can just say we can just delete red and blue, right? So we can do sampled dot r equals 0, sampled dot g or b equals 0. And then we should see green text. Yep, pretty. And then if we wanted to do like some sort of like CRT effect on the screen, we could do something like take the Y position and say like adjusted chord.y. We can take the sign of that to like get like some sort of like periodic effect. And we can say like background is equal to this. And we can say sampled plus background. We probably want to multiply this by, we want to take this from the range like -1 to 1 into the range 0 to something small. So we will add 1 and then divide by, you know, like 10, right? Because we want to like get this into a small range. And we need to make sure that this plus is executed before the divide, so we throw it in back brackets. And so we are seeing some sort of background thing, but we're not seeing it like oscillate the way we want. So we want to like maybe multiply the frequency here. And there we're starting to see like some sort of banding, right? Which is what we're looking for like a CRT effect. It's too big, so let's like really get the like, yeah, that's starting to look like what I want. I'm looking for like CRT banding green is like kind of, let's see if that gives me like, yeah, like this kind of effect, I guess is what I'm going for, but like with like more horizontal bullshit, right? That's kind of what I'm looking for. So we want those bands to be green, not gray, and we want them to scroll with time. So here, our out color here, instead of being that, we're going to be background. So we'll see vec3 background with a little glow around the letters. That would be sick, yeah. That would be really cool. I don't know if we're going to make it there, but that would be pretty sick. Okay, so there's like some little banding, and then we need to make our bands green, of course. So this is actually more like 0, 0, background, 0. Okay. Plus, I guess here our background should be a vec4 up here, which makes vec4 0, this shit 0, 1. Nice. Yeah. And then here, our out color is background. Otherwise, we have sampled plus background. Okay. We have some fucking syntax errors. All right. That's looking pretty decent. And then maybe we have it like scroll with time, right? So we'll do like uniform sampler 2D, no, uniform float time. And we just add time here. Maybe we add time. Yeah, adding time here is fine. And then in our Rust side of things, when we render this, when we do this post-processing, we just add in self-time. Great. And because we already have like this concept of time that's being tracked externally, time will be a float32. And he now needs to set that uniform. So we have to look him up. So here we say the location of time is going to be the time in the program. We're going to write that down in our state for our shader. And then when we render, we just say we set the time loc to be time. And we see what happens there. I see no movement. So either we need time to accelerate faster so that we see more movement. Or something else that I don't have to think about. That's pretty sick. We need time to go faster. Exactly. um, that's pretty slick. That's pretty slick. I think we're getting close. What else? What else should we do here? A glow around letters would be cool, but like glow is kind of a difficult concept. I guess we have signed distance fields for our text. So we could kind of leverage that in some way to get like some like background. Yeah, we could. Yeah, let's try that. So when we render our glyph renderer, he uses, I think it's like SDF fragment. Nice. And here we could say if the value is great, like less than 0.5, we just say fuck it, we don't want you. But we could like adjust that to say if the value is less than like 0.4. And hear me out, hear me out. So the way that these like signed distance fields work is if I have like a letter, let's like letter T, right? At each point in here, they store how far we are from an edge. So maybe a T is a bad example because it's pretty linear. Is there like, well, we'll just draw our T even fatter. How about that? We'll make a really fat T. And so here they're gonna have like, here they're gonna be like, I'm 2 away from an edge. And here's gonna be like, I'm 1 away from an edge. And here's gonna be like, I'm -1 away from an edge. And over here is gonna be like, I'm -2 away from an edge. And then these seem to be like normalized to some range. We were like thresholding on 0.5. So where 0.5 is like, I'm right on an edge. And so to get a glow, we could say if we're less than 0.5 by not that much, we could kind of like make some sort of fall off function for that. So let's just right now say if we're less than 0.4, we discard. Else, if we're less than 0.5, else we do what we were doing before, we just like render normal. And here we're gonna like maybe say that the oh, we already have some sort of like alpha blending here. We could maybe just make like less aggressive alpha blending. Well, let's think. Let's just say color is this. That will we'll at least see what it looks like. Color from a non-numeric data type. I just want to like see where we would be affecting it, you know? Alpha doesn't exist here, which is why. So we'll just fucking blast me with it, please. Not good enough. We're not really seeing jack shit. So why is that? Say if val is less than 0. Right? Let's just keep all values there. Ah, okay. So that's kind of what I was looking for, right? If we say we threshold on like nothing, we get blocks everywhere. Oh, maybe 0.5. Maybe it isn't on 0. Like, how do I say this? Maybe the threshold of like the line is still at 0. But I was just thresholding to get like some, to like be a little bit inside or something. Like if I make it less than 1, we discard, or less than -1 is what I was trying to see. Interesting. So it looks like 0 is everything. Oh, maybe their signed distance fields don't keep track of like outside or something. Like maybe 0.0001 means it's inside. Yeah, that's what it is. So 0 is everything that they don't keep track of the distance of things outside, only things inside, which makes a glow a little harder. Okay. Today I want to make sure that we continue, like, I want to make it so that we have something that looks about right. Because if I decide not to come back to this project, I want it to be like in like a kind of reasonable state. So I think the last thing to do here before we finish off is to put some like walls in the background, which I think we had somewhere. We do have these walls, so let's just say export obj of the selected thing, triangulated. Apply modifiers. Can I apply translation as well? Doesn't look like it, but I think it's already applied. So let's put the walls back there. And stream start screen, we'll call it walls.obj. And in our main, let's pull in the walls like we do everything else. So we have, for now, we will just reuse the table texture for the walls because we don't have one yet. And we will import the walls from walls.obj. Okay. We upload the wall to the GPU. Nice. And fix me errors for walls match table. And then we need to write that guy down. So we say walls here. Where this guy says he's a table, we say please keep track of the walls as well. And then when we render everyone, we just have to say please render the walls as well. With identity transform. Okay, so now we should see like background, which looks totally fucked. That's great, love that. How can we see what we did wrong? Let's move our camera. We'll see if it's related to perspective. So somewhere we can disable perspective and see if the walls stop looking like absolute shite. Okay. It's probably because the walls that are behind us are ending up inside the camera as well. So really what we should do here, just to avoid causing problems with our renderer, is just delete some shit. Let's delete all of these vertices and delete this vertex. And then I guess in our scene, maybe this is good enough. Could be. Okay, let's try that. File, export, obj. And we export the walls. And then we go, oopsies. Then we go back here and we run again. And it still looks fucked. Still looks fucked. And the question is, why? Why? So, is it because we didn't triangulate our mesh? That seems likely. File, export, obj. Please be triangulated. It is triangulated. Okay. Is it possible that the normals are facing the wrong way? These look right. Let's see. What else? How could we test this? We could move the camera around and see if that gives us any intuition on why it's fucked up. So wherever we set the camera position, we set the view matrix. And let's just spin the camera around or something. So we'll say X position is F32 cosine time, and the Z position is sine time. And we'll keep this old version of what we were doing, but we'll copy paste this to something that moves with X and Z. And we'll move the camera back on Y as well. Alright, let's see. So here it feels like I'm seeing, like, no fucking wall at all. Oh, there's something back there. Can we, like, turn perspective on so that we can see? Right, like, I would think that we should... Is the scale of this thing not applied? Ooh, apply. All transforms. Save. That could have been it. It could have been that he was scaled in Blender, and that wasn't making it into the world that we were looking at. Where is my terminal? I lost it. Here it is. Cargo run. Am I high? Like, why is it back there? Let's reduce the height of my camera a little bit. View matrix. Right, let's set him to like 0.1 or something so that we can like see a little farther. It looks like his translation is off and his XY is off. What the fuck am I missing? So we have 3 faces. Did I scale the table? I didn't scale the table, right? This table, I think, is just applied directly. Table is used with identity. And so the walls should also be done with identity. And so, like, if in this scene the table and the walls match up, then, like, why wouldn't they in that scenario? We could import the table object and see if it lines up. It could just be that they're just, like, completely different scales because I might have just all modeled them separately. File, import, obj, work, stream stimulator, no, stream start screen, table. And no, that desk is like the perfect size, so why the fuck are the walls not? Hello, what are you creating? We're making this like stream intro screen that's supposed to look like this kind of, where like what's happening on stream ends up on the monitor, and like this will be like animated to say like how long till stream starts, etc. And we're using it as an excuse to like explore 3D rendering in OpenGL. So we do have like this thing here where we have like it's getting rendered on there. We're setting up like cameras and walls and scene and stuff right now. We've got like 3D lighting, shadows. Interesting. So I actually somehow fucked up the table there too. What the fuck? I might have actually accidentally re-exported the table actually, so let's just make sure that we didn't do that, and we'll import that table into Blender again. Import. OBJ. Table. Aha! Yeah, okay, yeah. Okay, I'm seeing it now. So here our walls are just not in the right fucking location, which make a lot of sense, so let's just fix that. So we want fuck all this shit, fuck this, and all we want is this wall here, and we just want to put him in the right spot. Oops, wrong side. There we go. That's much better. Much better. And we probably want to make sure that the table is actually lined up. Perfect. Perfect. And let's export this guy now. Export. And I guess we need to apply all transforms before we export him. And hopefully now everything looks a lot better for us. So we'll import the walls. Cargo run. And that does look better. I think that the X of our world is actually inverted from Blender's, which is kind of annoying. So maybe what we'll do is when we export the walls, the forward axis should be positive z instead of negative z, and then I think that that'll fix it. Oops, wrong axis. Instead of positive z, negative z, maybe we want it to flip x. Let's try making it negative x. That's also not right. Now he's kind of like the wrong shape. So clearly z was the right negative z was right. But then I guess maybe our right we might have x going just like in the opposite direction that they do, which is kind of annoying. Can I say to invert everything and then make negative y up? No, that doesn't work either. Oh yeah, that's annoying. Annoying. I guess we'll just invert it here, or we can set our scale on the one of the axes in Blender to -1. God, that's so fucking annoying. Whatever. So here, I guess we'll say from scale, and we will invert our x-axis. Fine, not from scale. Previous Mick wrote scale, so we'll listen to him. He knows best. Okay, we're close. We wanted to invert z, not x. And there we go. There are the walls we wanted. Perfect. That's pretty funny that the shadows are cast on the back of the wall as well. I didn't really think that. I never thought about that. That's funny. Okay, so now let's make a wall color. So the walls should be like, I guess like an off-white. I guess the lighting will make it look off-white, so we can just make the walls white. So we'll open our our texture, which is just 1 pixel. Because we you see this like really tiny pixel here? It's because we only have like a renderer that renders textures, not individual colors. And instead of making a proper shader, we took the lazy way out and just, you know, sample single pixel. So somewhere here now, we, instead of pulling the table texture, put wall texture. And there we go. That looks depressing as fuck, which is kind of what we're going for. And now let's just stop rotating the camera and put him back where we had him before. Like this. And turn perspective back on. Interesting. So something about that's getting like totally fucked. Oh, because I turned perspective on for the lights, not for our actual render, which is wrong. So let's fix it here. Cargo run. Looking pretty good, except the wall is fucked up, probably because we're inside it, so. Ah, classic. Alright, that's fucking annoying. That is so annoying. So I think almost certainly this will fix itself if we fix our perspective matrix. And yeah, you can tell it's because our camera is just like way the fuck back here, and this line is like in the way. So we probably have to do something like not draw back faces of things, or not draw things that are like inside of us in some way, right? Because when we turn perspective, this corner here just like comes like way into our face, which is annoying. We can also like, yeah, we can do some like FOV adjustment stuff. How do I want to handle this for now? For now, we could just render from the right side, blaze it instead of the left, and then that kind of solves that problem for now. Even though it's not how I want it. Alright, so if we render from the right side, oh, it's still fucked. That's cool. Love that. Love that. Oh, God. Oh, God. What have I done? What have I done? We want to disable perspective here. How do I want to handle this? Well, eventually I'll have to fix perspective, but I think we can maybe dodge this by making our view matrix also scale everything by 0.5 so everything looks bigger. Maybe even more. Make everything fucking massive with an orthographic view. Maybe 1.5 is too much. But we could do it, you know, something like this, and then maybe look at from a little farther to the right. Maybe something like 0.1 to the right. Nice. And I want to look from like a little farther on top, so maybe we'll look from like 2.5 up. That's not looking too bad. That's not looking awful. You know what? I'm okay with this for now. I kind of want to put an end to this project because I'm kind of not super interested in it anymore. So I just want to get it to a point where we can kind of call it done. I think we're very close here, very close. Maybe we'll shrink the world a little bit more. And just move the camera ever so slightly up. Ever so slightly. I think that looks pretty damn good, to be honest. Let's maybe just a little bit to the left as well. We want to look a little bit like along Z, maybe. In the like 0.1 on Z. Does that put us in the right spot? Nope. What the fuck? Actually. What is this like API to look at? We have three things: center, up, and I. So we just want to put our center farther to the left. Like this. Yeah, you know, something like that. It's not going to be... I'll probably play with it a little bit, but I think that... that's pretty slick. Pretty slick. I think I'm going to call it there. There's some more work to be done to fix perspective and stuff, but I think I'll do cleanup and fixes off stream because I'm getting kind of bored of this one. Thanks for watching. If you liked what you saw, I stream most days around like 1 or 2 Pacific time. I think that I'm probably going to take 1 or 2 days off coming up, but I'll be back on Tuesday or Wednesday. And I think the next project I want to work on is something like AI related. I have an idea for like a project where we find the best ASCII character. If you were going to do like image to text to like render something in the terminal, it would be kind of fun to find like what is the like optimal representation of this in ASCII characters. And I think that it would be kind of fun to train an AI model to find that for us. So I think that's what we'll be back with on like Tuesday or Wednesday. There's a YouTube channel if you want to watch VODs and you like miss stream. So that's linked in the Twitch description. There's a Discord linked in the Twitch description. And if you're watching on YouTube and you want to come by and tell me why I'm bad at coding, or, you know, shoot the shit, whatever, there's a Twitch link in the YouTube description. And as I said, most days, 1 or 2 o'clock Pacific time. So yeah, thanks for watching, guys. Catch you on the next one. Bye!